Look at almost any weather app, look at a children's book or an emoji keyboard, and you will see the exact same thing, a perfect, crystal clear teardrop falling from the sky. This seemingly pristine water cycle is the engine of life on Earth. It waters our crops, fills our reservoirs, and keeps billions of us alive, all delivered entirely for free. But there is a catch. If the water hovering above us right now were actually 100% chemically pure, it would never fall. High-speed microscopic cameras completely shatter that classic teardrop image. A falling drop of water cannot hold a pointed top and a rounded bottom at the same time. The aerodynamics simply do not allow it. So if the iconic pure teardrop is physically and chemically inaccurate, we have to ask what exactly is raining down on our heads right now. High in the atmosphere, energetic water vapor molecules bounce erratically, moving too fast to bond. To transition to a liquid, these frantic molecules need a solid anchor, a non-gaseous surface to crash into, cool down, and stick onto. The atmosphere is heavily populated with these tiny anchors. Microscopic debris like evaporated sea salt, soot from fires, floating pollen, and wind-blown dirt get swept miles into the sky. Sometimes those anchors are actually alive. Updrafts frequently carry a specific type of bacteria called Pseudomonas syringae into the upper atmosphere. Pseudomonas syringae is a rod-shaped plant pathogen that has evolved proteins specifically designed to attract and freeze water molecules. Scientists call these floating pieces of dirt and bacteria called cloud condensation nuclei. A cloud condensation nucleus is simply a tiny airborne particle that water vapor condenses around to form a cloud drop. Every single rainstorm is actually a massive atmospheric sweep. Water vapor wraps around millions of floating specks of dirt, ash, and microbes, pulling them out of the sky and dragging them down to Earth. Once that liquid water collects around its microscopic nucleus and becomes heavy enough to drop, it begins descending as a perfect sphere. Gravity pulls the falling sphere down, while upward arrows representing air resistance push back, flattening the drop into a hamburger bun. At 5 millimeters, air pressure punctures the center, forming an inverted parachute that quickly explodes into smaller spherical drops. The long, relentless fall from the clouds is a brutal, chaotic battle between fluid dynamics and atmospheric drag. The water is constantly battered, flattened, and fractured, never once taking the shape of a calm, elegant tear. When you look closely at the physics and chemistry, a rainstorm reveals exactly what it is: countless microscopic capsules of earthly debris, tightly wrapped in shells of water and violently reshaped by the air. This exact thermodynamic mechanism, vapor condensing around floating impurities and dropping from the sky, plays out across our entire solar system. The physics hold true on other planets, even if the chemistry turns hostile. On Venus, extreme atmospheric pressures drop intense showers of sulfuric acid. On Saturn's moon Titan, the lakes are filled by heavy storms of liquid methane. The rules of gravity and gas are universal. So the next time you feel a rainstorm start and a drop hits your skin, remember what is actually landing on you. It is a tiny, aerodynamic parachute, carrying a microscopic speck of the world safely down to the ground.